Welcome to another Ultralight Airplane Design video from Ultralight Airplane Workshop. This is part B of a video that I started back in December. Right now it's June, so it's been a few months. Now in that video I talked about how I wanted to do some testing for portions of a nose rib for the UWS-4 Ultralight airplane, ultimately. But this is kind of more generic testing. It could be applied to other airplanes too. What I'd like to do for the UWS-4 possibly is to have a cantilever nose rib. So this is a cutout very similar to what I'm thinking of doing for the UWS-4. This is correct scale. So this will be a cantilever style where all the load is taken by a beam up here and a beam down here. Whereas a truss style would have a cross member in here and probably a vertical here to help take the load. Now this is potentially a heavier rib design if I do this. But I just don't know because I don't yet know what shape these corners have to be in to take the cantilever load that we're going to have on the nose. And by the way, that nose would be up this direction. It's about 90 pounds. And if you concentrate that 90 pounds in one point, that would be about 12 inches from where the shear web would be on the spar. So about in here. So what I decided to do is just test a portion of the rib. This corner here and this corner here. And that is essentially what I have here. So in this case, it'd be this corner. Or you flip it over, it'd be this corner down here. And so what I want to do is put some weight out here, pulling down and then pulling down in order to test these. Now I'm pulling down in this condition, this is going to be at a compression here, so I don't expect it to be able to take as much load as in this condition where this corner here would be in tension. It should be able to take more load this way. So this would actually take probably most of the load on the rib. And by the way, I've got far more detail about what I'm talking about here in part A, and I'll put a link to that video up here in the upper right hand corner. Let me talk about how I'm going to do the testing. As I said, we're going to start with a portion of our rib, bottom corner or top corner. Now I want to emulate the skin and spar too, just to make it more realistic. This by itself is very flimsy. It holds almost no weight at all. But what I'll do is something with this. So again, here is the corner piece of the rib. Now this is a piece I did some testing with it, so it's already been damaged a little bit. But I have a skin that I'm going to rivet to the top or the bottom of the rib. And then I have something that represents the spar too. I have this that represents the spar web. I have this represents a spar cap. And I have a little stiffener here. Now the stiffener serves double duty. It's what I use to clamp into my vise to hold it still while I'm doing my testing. Now I've got this little bit out here, which now is not in the right position. It should be more like this. And I put a weight here, either a weight pulling down this way, or when I'm in this orientation, a weight pulling down this way. Now, as you can see from this little test I did, the failure wasn't actually in the rib. It failed over here where I had my weight attachment. But let's talk about what I attach here in this place for the weight. And that is this little carriage here. So here's the shackle that goes in that little hole. So like this. And then here's the sensor for my scale. And here's the scale here. And then here's the little carriage I have to put weight in it. And the weights that I'm using are floor tiles. I have a whole bunch of these left over when we did some house remodeling a number of years ago, and I've been using them for weights of various kinds for a long time, and they're very fantastic for that. Each one of these weighs about 1.5 pounds, 2 pounds or so. And they work great for putting in here and adding weight a little bit at a time. Now I have some video I'm going to show you of some testing I've done. I'm not going to show you all the testing. I did quite a bit. I'm really going to show you the best tests that I had, the configurations of various roundness here, flange width, and flange angle that worked best. But I'll show you how they failed and how much weight they took when they failed. So let's get to that. Here's the setup for testing the upper corner of the rib. So as you can see here, this is the outline for that rib. And for dimensions, this inside radius right here is 3 inches. The size of the flange is 1/2 inch, and then the angle of the flange is 45 degrees. And to make it a little bit more realistic, I've added a skin. You're seeing it edge on here. And then right in here is the spar cap. The spar shear web is down through here. And you can actually see a little flange of it I added to make it a little bit stiffer here. And then the other stiffener that's attached to the vise, right here is the vise. So you can't see it very well, but right in here is that little angle stiffener that goes into the vise right here. So where I add the load is right in here. Of course, there's a shackle here, a little eye bolt here. Right here is the load sensor. And of course, it runs over here to a display. Now I've got another camera showing the display, and I've got it inset for that here. And then you can see it's already showing 2.4 pounds. And that is from the carriage that is right here. Actually, it's attached here to the load sensor. And then the carriage is down here a little bit low. And that's where I'm going to add all these weights that you see back in here. So what we're going to do now is I'm going to run a little video clip showing me loading up the carriage. And right before it fails, we'll stop. And then we'll go through a little bit slower and see what happens. As I was adding weight to the carriage, I happened to notice that right up in here, this flange was bending toward where we're looking at right now, towards us. And I was a little surprised by that. I'd never noticed that before. So here you can see me taking a macro shot of it. Let me show that to you. So here's a view of that rib from that camera angle we just looked at. So this is edge on. So you can see that this edge here actually should be more along this angle here. So it really should be more like that. So you can see it has bent over quite a ways. It's not 90 degrees. It's probably close to 45 degrees or so that has bent over. And in fact, it's almost touching right here, this little flange that I bent for the spar web. But it's still holding the load, so I decided to go ahead and continue testing. Oh, by the way, in the real application, down below here, this would go on to the spar bottom, and this is a compression up here, but down below it would be in tension, so it would actually be trying to pull this back straight, so it wouldn't bend like this quite as much in real life. So we're looking at this in slow motion now, and I want to stop at this point right here. Because this area here where this flange is, it's almost, at least right here, looking at us almost straight on. So it has been out a really long distance. But it hasn't had a failure yet. So let's continue watching and see what happens. So I wanted to stop here again because now we can see where the failure is. So right here, there's a little bit of a crinkle. So this is where it's failing right now. This is the worst, or at least this is the start of the failure. And then it actually progresses up on a little bit farther, and we get more failure right up in this area right here. So let's continue watching till the end here. Went back in the video and grabbed this little screenshot of where we had the failure, and so it failed at 18.1 pounds roughly. It was probably just a little bit more than that because the scale doesn't update really rapidly, but it's okay. We'll call it 18.1. We could add a few more ounces for this shackle over here, but let's not bother. So that's the best failure for a top rib that I've had. That's not great, but it's not completely horrible. We really need to compare the bottom rib failure, the bottom corner failure, and see what happens there before we can really make a full analysis here. So let's go ahead and do that. I'm going to show you two clips of a bottom test failure. Let me give a quick introduction to this test. So again, we've got our rib here, except this time it's in the upside down, so the bottom section of the rib. And once again, the radius here for this inside curve is 3 inches. The flange should be 1/2 inch, but the angle for the flange is not 45 degrees. I've been sticking with the flange that I got off of the form block, which is somewhere between 25 and 30 degrees. And it's not quite as much as in the next test. And then I wanted to go ahead and point out the rivet spacing. So the rivet spacing here on this skin is 3 inches, except for between the spark cap rivet and the next rivet. And if I remember right, that was 2 inches, if I remember correctly. And another thing that's a little bit different on this one compared to the next one is I had been holding it in the vise a little bit too far down on it. On the next one, I actually put it on the vise up a little closer to here so that it can be supported down low. So as you see me put weight on this stiffener here is actually going to bow out just because I didn't have it rigidly held in the vise, but that's okay. So let's get going here. All right, here we go. Oh dear. Got a terrible buckle there. Wow. So I've rewound just a little bit here so we could see right before it failed. I just put the last piece on, and right now the scale is reading 50.9, so roughly 51 pounds, pretty close to that. But you can see I had a little trouble with this bending out this way as I put more weight on it, which means that this weight right here is not really perpendicular to our rib, which is what I really wanted. So the actual weight that is perpendicular to the rib this way is going to be just a little bit less. But for now, it doesn't really matter because the next test is even better. But I really wanted to show you this failure because I thought it was pretty interesting. So, as you may have noticed earlier, we got a significant bow right here in the skin. So all the force is being carried here by our rib. The skin's not carrying anything right there. And because that gave me an idea what to do on the next test. But let's go ahead and in slow motion, I want to show you the failure on this rib here. Now, I don't know if you noticed it or not, so I'm going to just do 2 frames here from that little slow motion. So here is the first frame I want to talk about. So right here. Now, if you had just looked at it in fast motion, you would have thought that what probably happened is that it tore just above where this arrow is on the top edge. Up in here, you probably would have thought the failure was that it tore there. But that's not what happened first. The first is that it buckled right here on the flange. It buckled up first. And then, just like a couple frames later, then you got the tear on the top. But the first failure was buckling here on the flange on the bottom. And so that gave me idea to what to do for another test. I wanted to do another test anyway, where I made the flange up here 45 degrees instead of between 25 and 30. So I figured that would help. And then I thought, aha, what I should probably do is stick another rivet in here. I went ahead and stuck another one here just in case. And then I wanted to test it again and see if we could get an even better load capacity for this bottom corner rib. So let's look at that. I won't show you the whole lead up to it. Let's just go ahead and jump to the end, or pretty close to the end. So I'm starting here roughly where the last test failed. So right now we're at 51.4 pounds. So you see in the location where we had that significant bend and the failure point in the previous test right in here, we're getting almost no bend. But there is a little bit of bend right here. Not a lot, but a little bit. So we'll talk a little bit about what my plans are to do with this a little bit later. Let's go ahead and run this test and see what happens. Okay, so that failed first. So this test did not fail the way I expected to. So this fitting here that I had riveted to the end of the rib started twisting. The more weight I put on it, the more it twisted. And so that actually finally flipped sideways and caused the failure. It should have failed somewhere back in here, but it didn't. So I didn't learn what I really wanted to learn, but I did learn that putting more rivets in here, slightly closer spacing of rivets right in this area, that'll help a lot. So I'm guessing that I can probably get over 60 pounds of load on here without it failing. So I'm starting to get fairly close to the load that I need for this to carry. But like I mentioned before, I'm getting some odd bending up in here that should probably not happen for an entire rib with both top and bottom corners. The top corner should carry some load. So I'm starting to get fairly close. I'm guessing at the moment with the failures I currently have, just considering them apart, I think I'm getting at least 60 pounds of load for this rib to be able to carry. I mentioned earlier that I couldn't remember the exact lift I needed on the nose rib and where that moment arm was, where if you concentrated it, where that would be. Then I remembered I had made this spreadsheet back during the wintertime that had some of the testing out that I did. So the nose rib lift has to be 61 pounds. And then 90 pounds would be with an additional 50% for safety margin. And then the arm for that is at 11.5 inches in front of the spar. So you multiply those two together to get the moment, and it's minus 713 inch-pounds. So let's come over here to some of this data. So this is whether I'm doing that corner of the rib in tension or compression. So here's the compressions. I've only captured 2 of the tension ones. Then the thickness of the material, I'm using 20 thousandths of an inch. I did one test with 16 thousandths just to see if there was much difference. The radius of the flange that I'm using, so I went from 1 inch up to 3 inches. The width of the flange, so 1/4 inch. I even had one that was an 1/8 inch. That was an accident, but I went ahead and tested it anyway. And got 1/2 inch. So these are the ones I did near the end. The angle of the flange, so coming off the form is around 27 degrees, and then I did some additional work on it with a little tool to change it to 45. The width of the web, I did 1/2 inch on all those. Then I captured the weight where we had the failure at, how far that arm out was, where that weight was, and then I got a moment number. So as you can see, the best ones I got, at least in compression, were with the 3-inch radius and the 1/2-inch flange at 45 degrees, which is to be expected. And so I got a moment of 168 inch-pounds for that. So that's actually pretty good. There might be ways to get it better. And I'll probably think about that a little bit to see if there's some ways I can get a little bit better without adding too much more weight to the rib. And the best one that I got in tension with at least a reasonable test was, again, with the same exact rib. So 3-inch radius, 1/2-inch flange, 45 degrees. Actually, it was 27 degrees, pardon me. Although there isn't a whole lot of difference between when we're in tension between the 27 and 45 degrees. So that failed at roughly 51 pounds. So we got 487 inch-pounds for the moment there. And then I did the test again because I added some more rivets. So I figured that would work a little bit better. And of course it did, but if you remember, my fixture for holding the weight twisted and failed. So I didn't quite get what I wanted, but I know it can at least be about 520 inch-pounds. So let's add those together real quick. So that's 687. I need 713. So I'm getting pretty close, but that's without safety margin. So I think when it's all together in one rib, I think it's going to be more than some of its parts. I just don't think it'll probably be enough to get me up to a 90-pound weight. I'll probably go ahead and stick with this 3-inch diameter curve here on both the top and bottom. I'll probably have 1/2-inch flange at 45 degrees. I still do not yet know how I'm going to do the nose up here. That's something I still need to work on. And I will possibly put a vertical piece in here too. But that's something I want to think about for a couple days, and then I'm going to go ahead and cut some more aluminum. I'm going to completely wrap it in a 6-inch wide piece of aluminum skid all the way around. I'll probably do the spar back here fairly similar to what I did here. And then we'll do another test. And I may have to go and find some more weights because I'm starting to use up a lot of my weights down here. So I may have to either get a bigger carriage or find something else that I can use for some weights down here. Well, guys, I hope you found this interesting. I certainly did. And it's give me some encouragement that I can actually make a cantilever rib, or mostly cantilever rib, work here on the nose of the UWS-4 Ultralight airplane. I just about gave up and went back to a truss style here on the Part C for this video, but I'm going to go ahead and we're just go ahead and try a full-size rib cantilever, see what happens. And then if that doesn't carry the load, we'll go back to a truss style and we'll have a Part D. Thanks for watching, guys. Till next time.